I said to Logan earlier today, if I do my job right today, I won't teach you a thing. I'll just confirm some stuff. What we're going to be using, it's on your green sheet, but if you want to stick it on the top of your page, we're going to be using the idea that change in momentum or impulse is also force times change in time, and it's also mass times change in velocity. Although we're going to also sometimes say, Logan, that a better way to write mass times change in velocity is mv final minus mv initial, because what's change in anything? Final minus initial. All right. A force of 8 newtons acts on an object for 10 seconds. The mass of the object is 4 kilograms. What's the magnitude of the object's change in momentum? What's this question asking me to find, Antonio? No, it's not asking me to find momentum. I got to be really fussy here. Riley, look over at Antonio, shake your head in pity because you were away and you figured it out. What's it asking me to find? Which is different from just plain old momentum. It wants me to find that. And whenever they, oh, by the way, what's another word for change momentum? So they could have said that. Whenever they say that, the shortest way to write impulse out of all of these is that one. I write that down first as my brain starting point. And then I think to myself, I can either find the change in momentum using force times change in time, or using a final and an initial velocity. Antonio, which method am I going to use for this one? Look at the data that they gave me. Yes. Okay? Because I see newtons and I see seconds. I've told you more than once that it's worth memorizing what units go with what, because it really does cut down on your thinking. Keep going, Antonio. What is the force? What is the time? In your head? Units. You could say kilogram, meters per second. Here, because I went force times time, my brain would probably just write Newton seconds because those happen to be the units that were in my brain. But at the same time, if you wrote kilogram, meters per second, Ben, I'll give you full marks. Direction. I forgot to give you one, which is why I said magnitude. But whatever direction the unbalanced force is, that's the direction of your impulse. Riley, you're on. What's the magnitude of the object's impulse? It's meant to be really easy. There's a reason why I gave you no space to do any calculations whatsoever. Because another word for impulse is change in momentum. Another word for change in momentum is impulse. That was the theme of the lesson that you missed. Now, the good news is if you both pay attention, you can probably pick up what you missed from last day. 80. And you could again say Newton seconds, or you could say kilogram meters per second. Ooh. Logan, what's C want me to find? Thank you. Sorry, what? That thing. Well, now I think I'm going to write this equation. I think I want those two. Why did I do that? Because I already know the impulse. How would I get the change in velocity by itself? What's the m doing to the delta v? Adding, subtracting, multiplying, or dividing? So how I move the m over? Yet another equation that we can derive, I hope, yes? So the change in velocity is equal to the impulse divided by the mass. Have I taught you anything new? I hope you're saying, oh yeah, I never thought of rewriting the equation that way, but duh. What was the impulse magnitude as a number? The change in momentum magnitude? 80. And what was the mass? I gave it to you in the question. Go read. I gave it to you. Yep. 80 divided by 4 in your head. You can use a calculator if you have to, but thank you for getting your calculator out. By the way, I would do this in my head in my homework. I gotta be honest, on a test, I'd probably use a calculator because, Riley, I've done dumb math mistakes so often. Quizzes and tests, I use calculators for everything. Even for, I mean, maybe not for timesing by 1, but almost anything beyond that. 20, yes? Yeah. And you're going, oh, I should have done that in my head. Yeah, gotcha. Units, well, it's the change in velocity, so it's going to be meters per second. Now, that doesn't tell me the final velocity or the initial velocity. That tells me what it changed by. How much did it change by, Logan? 20. So, if my final velocity was 2 meters per second north, if my initial velocity was 2 meters per second north, my final velocity will be 22 meters per second north. If my initial velocity was 8 meters per second east, my final velocity was 8 plus 28 meters per second east. So here's the question, Jackson. If my final velocity was 12 meters per second north, what was my initial velocity if my change in velocity was 20? Good. Ready? What's change in anything from last day? Okay, here's what Jackson went. I can't remember. You know what? Also at the top, let's write down triangle equals final minus initial. Change in anything is final minus initial. So I can write this as final minus initial. You agree? What's D asking me to find? What's right in front of the VI that I don't like? What's right immediately, look up, what's right immediately in front of the VI that I don't like? Swappy dance. Not for forces, but I'm telling you, I may as well use that trick. Jackson, I'm going to plus the VI to this side. I'm going to minus the delta V to that side. And I hope you're going, oh, yeah, I never thought of that, Mr. Good, but that makes sense. You're not teaching me anything new. And I get this. VI equals VF minus delta V. You okay with that, Jackson? What was V final according to this question? D told us. Read part D. No. Read part D, the instructions that they gave us. What? You were way overcomplicating that. Yes. What was V final? Say it again. Minus, what was the change in velocity, Logan? What was the change in velocity, Logan? I'm bringing you back to the one that you solved. Jackson, what's 12 take away 20? This is negative 8 meters per second. What direction was V final? Jackson, what direction was V final? So this is negative 8 north. What would a better way to write negative 8 north be? Oh, sorry, were you all going to give me the answer, or did I do something wrong? Yeah. Okay. This object must have been going south first. Some force pushed it north so long that it came to a stop, changed direction, started going north faster and faster and faster and faster, and after 10 seconds, it was going 12 meters per second north. We changed its velocity by 20 meters per second. Okay? Example 2. Blah, 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 blah. Y'all read it? Julianne, what are they asking me to find in part A? So first thing I'm going to do is go to the shortest possible way to write that, delta P. But now I'm going to think to myself, 2 ways I can find the impulse, the change in momentum. One involves a change in velocity, one involves a force and a time. Which method am I going to use here? And in fact, instead of writing look up, look up, look up, look up, don't write this down. Look up, look up, look up, don't write this down. Instead of writing M delta V, can I just go straight to saying what's change in anything? I'm going to go M VF minus M VI. Final momentum minus initial momentum, because momentum is what times what? Mass times velocity. You okay with that, Sam? Yeah. Julianne, what's the mass? What's V final? Minus, what's the mass? 350. What's V initial? Pause. Read very carefully. Make sure there's no changes in direction. We had one last class where we had to let one velocity be positive and one velocity be negative. Is there a change in direction in this question at all that you can detect? Well, then we can call it positive as well. But always get in the habit when you're doing that second one of checking, because vectors matter again. What's the impulse? What do we get? And by the way, I should have said what magnitude of change in momentum, and I'll change that again because I didn't give you a direction. Sorry, what do you get? 5425. Anybody else? Units? If you said Newton seconds, I'd give you full marks. But in my brain, since I just went mass times velocity, I would probably come up with kilogram meters per second. By the way, if this was answer key, I'd probably go to 2 or 3 sig figs. I'd probably write it as 5,430 or something like that. I had a few of you from the homework saying, Mr. Duick, I got this wrong. No, I just rounded off. Right? Okay. Hopefully I haven't taught you anything new yet. Jabber, what's B want me to find? Now, don't write this down. I could go F equals MA because they gave me a mass. I could go, well, A equals question mark. I could go VF minus V equals, sorry, I'm doing this badly. I could go VF equals VI plus AT. I could get the A by its, wait. Jabber, what did I find in part A? Is there a version of change in momentum that has a force in it? Why don't I save myself? This is why I'm trying to communicate to you the impulse equation. It's a nice shortcut because I think I can also write the change in momentum equals what? And how would I get the F by itself? I think I saved myself 4 lines. Yay. Again, can you survive perfectly fine without it? Yep. All the stuff from before Christmas and little F equals MA will work. But, draw a little arrow. Shouldn't say they're equal because we're finding the F by itself. F equals impulse divided by time. It's going to be 5425 divided by 60. By the way, I could also, instead of saying 60 seconds, have told you that the time was 1 minute. Please check for units and do the conversion. I don't have a big issue giving you time in minutes because that's also another way that we measure it in the real world. What do you get? Sorry? 90.4? Even? Or does it repeat? Okay, so 90.4. Units. Force. Direction, I don't know, because they didn't give me any whatever the direction of the impulse was, that's the direction of the... Next page. Rockets. We can start to do a little rocket science. A rocket of mass blah blah starting from rest is acted on by a net force of blah blah blah. What's the final velocity of the rocket? We could do this in about 6 lines without knowing the impulse equation. But you want to use a shortcut? I'm going to write impulse equals impulse, but I'm going to write it differently. Look. I noticed that they gave me a force and a time. I noticed they want a velocity. I'm going to write the version of impulse that has force and time and velocity. Look up. I'm not going to write that. Instead, I'm going to write force times time equals mv final minus mv initial. Isn't that also impulse equals impulse? I'm taking the other 2 parts of that impulse equation. How did I know to do that? Well, they didn't specifically give me or ask for the impulse, but I noticed they wanted one of the subparts of the impulse equation of velocity, and they gave me force and time. Okay, other stuff. What do they ask me to find, Courtney? What is the... You know what? I'm going to put a little dot above that because that's what we're trying to get by itself, and this is a little more complicated. Okay? How are we going to get the V final by itself? What's going to drop down like a domino? Ft. The other side. Right? How am I going to move this M over? What's this M doing to V final? Times how will I move it over? How will I move this MVI over? What's this MVI doing? So how will I move it over? Which one am I going to do first? Reverse bed mass. Right? So it's going to be plus MVI. And then? And do you mind, can I write VF equals? Hey, that sucker is not on your formula sheet. And this is why at the beginning of the year I told you, I can't come up with every single variation and permutation. You know what? I'll teach you how to derive them. It's a better way to do it. Another way to find V final. Courtney, did they give me the force? Okay, 2.3. I hope you just looked for a capital letter N. Is that what you... That's what I've tried to teach you. It's worth memorizing units. It makes word problems way easier. 2.3 times 10 to the fourth. Time, I'm looking for seconds, 120. I could also have said 2 minutes. Plus, not minus, because we plussed it over. M, 2.6 times 10 to the fourth. V initial, oh, wait. What was V initial? I could have done that. Why? Because V initial is, and so 0 times M is still 0. So you know what? Do that. Scribble that out. And I did this on purpose. I noticed it was 0, but sometimes I don't catch that. If you're wondering, how would I catch it later on? That's what I would do. Divided by M, which was 2.6 times 10 to the fourth. I'm going to strongly encourage all of you to type this into your calculator. Is this a fraction? Yeah. You might need to put the top in brackets. You don't need to put the bottom in brackets if you use your scientific notation button. So for me, on my calculator that I'm typing in, because I said I'd like to encourage all of you to type this in on your calculator, I'm going to go 2.3 scientific notation 4 times 120 divided by 2.6 scientific notation 4. Whoop, that's all wrong, Mr. Duke. I should close off the top just to be paranoid. On mine, I don't need to put brackets around the top, but on your calculator you might, and it's going to be scientific notation 4. I get 106. Yeah. And that seems about right to me for a final velocity of a rocket that's been going for 120 seconds. Meters per second. So this version of the impulse equation is really nice because it allows us to find a V final or a V initial in a new way if we know the force and the time. Now, here's what else you could have done. You could have said, what's it asking me? Don't write this down. What's it asking me to find? You could have gone V final equals question mark, V initial equals 0, T equals 120. Hey, I need to find A. Did they give me a force? Yeah. Did they give me a mass? Yeah. I can find A, but you'll notice we were able to do this in a couple of lines. The impulse equation is a nice shortcut. My point also, though, is if you can't remember on a test or a quiz how to do it with the impulse equation, do it the long way. I'll give you full marks. Riley, what's example 4 asking me to find? Good stretch. You're back. What's example 4 asking me to find? Comes after the word breaking. Starts with letter F. Force. Okay. This is a job for... No, this is not a job for a free body diagram. I don't think. I might be able to get there by doing a free body diagram and all sorts of stuff, but did they give me a mass? Did they give me a speed? Did they give me a V final? To a halt means V final is... and a time. I think I can use the impulse equation, the one that has both force and velocities in it. I can use this version. Force times time equals m v final minus m v initial. This time I'm paying attention. Was one of these 0? Yeah. Which one? Yeah. So let's all go. And that gives us force times time equals negative m v initial. Little nicer. Riley, what did you say this question is asking us to find? How would I get the f by itself? What's the t doing to the f? Multiplying, so I will divide. Yeah. Yet another equation for force. Please don't try and memorize all these. Do yourself a favor. Force apparently is negative m vi over t. It's going to be negative 1632 over 1.6. You get a negative answer. We'll talk about what that means in just a second. Franz, what do you get? You have your calculator out? Folks, I've been telling I want all of you to be doing this on your calculator. When I say that next time, if I catch some of you with your calculator still inside your binders, I'll snap. What'd you get? Negative 32,000? Units. It's a force. Units. Newtons. Why negative, Kenley? Are we speeding up or slowing down in this question? So if we're going forwards, the force would have to be backwards, negative. Or you know what? If we're going north, the force to bring the car to a stop has to be... If we're going east, the force to bring the car to a stop has to be west. Okay. Negative. So that negative doesn't surprise me. That actually, Courtney, convinces me I think I did this right. Hopefully I haven't taught you anything new. Just keep going. Example 5. Force, magnitude, and direction. Okay, this time they're going to want a direction of the ground acting on the rock if it comes to a stop in 0.35 seconds. Okay. What do they want me to find? Force. I'm seeing a mass. I think I'm going to try doing the same thing. I think I'm going to go F times T equals M V final minus M V initial. Impulse equals impulse. What's V final? Yay. So I get force times time equals negative mvi. I'm having a little deja vu. I'm having a little deja vu. I'm having a little deja... Riley, how will I get the F by itself? By... Thank you. Mr. Dewick, this is a waste of our time. This is the same question you just asked us. Yeah, I guess it is. Did they give me the mass? Did they give me V initial? Ooh. Smarty peoples, it's not the same question I just asked you. Even though this question is asking me to find the force, You know what I'm going to spend most of my time finding? How hard it hit the ground at. The impact velocity. Now, we often call this one V final, but we're looking at the impact after it hits the ground, and so this will be V initial when it hits the ground, and its final velocity was what? Okay. So, how can I find V initial? I think V initial is going to be V final when it hits the ground. Is that okay? I'm going to make a little note of that. V initial is going to equal V final on impact. So what I'm going to find is the impact velocity. What do I know? Here, since now we're talking the portion of free fall, VF is not 0. Oh, but what's VI? I think dropped. Hey, Mr. Duick, this is actually pretty good review from before Christmas for because we're actually not that far away from May and June and we're done in final exam. Yeah, it is. Oh, we know one more thing if we're in free fall, always. A is negative 9.8. What else do I know? Yeah. What's the distance? Thank you for catching the negative. Because we're ending up below from where we started. Looking for an equation that has a VF, a VI, an A, and a D in it. I think this is the squared one, yeah? Mr. Duick, what happened to the VI squared? Why didn't I bother writing the VI squared? I need to get the VF by itself. How to get rid of a squared? Square root. VF is going to be the square root of 2 times negative 9.8 times negative 40. Yeah. Negative 28? My calculator said positive 28. How the heck did you get a negative 28 from this? Yeah, oh, okay. Again, there's a lot of curveballs here, but hopefully you guys are doing a great job of catching them. I need to realize that whenever I square root, my calculator assumes I want the positive answer, which usually we do. Not this time. And now I can walk that over to here. The force is going to be negative. What was M? I've scrolled down. 2.5. V initial, which was V final on impact. That's V initial when we start to slow down. Negative 28. All divided by 0.35. Okay. Negative 2.5 times negative 28 divided by 0.35. I think this will work out evenly. Or nicely, at least. You get 200? That's the magnitude. But it also said direction. Did we get a positive answer or a negative answer? Did we get a positive answer or a negative answer? Mackenzie, what's a negative times a negative? So do we get a positive answer or a negative answer? Do we get a positive answer or a negative? Riley, do we get a positive answer or a negative answer? What direction did we let be negative? So positive is, well, of course the ground applies a force up. It has to, because this object is hitting the ground. It's got to push up on the object to bring it to a stop, which kind of is a Captain Obvious, but at the same time, yeah, up. You could call it north, but I have to be fussy. Can you all look at me? That's not north, that's up. North is at the back of my classroom, technically, right? I'll live with it if kids say up is north, but it's not. It's up. Up is up. Turn the page. A few more. I like example 6. I like example 6. I like example 6. Example 6 is a nice question. A ball moving at 4.65 meters per second east. A good habit whenever you see a compass direction is to somewhere in the margin write down a little compass rose. Because you've written something down, you feel better, but also because I've lost track of how many times I've mixed up east and west because I'm dumb that way. A ball moving east hits a wall. The wall exerts a force on the ball of that far to the west for that many seconds. Find the final velocity, magnitude, and direction of the ball. I think, again, Jackson, we're going to use the impulse equals impulse equation. We're going to say, I see a force and a time. Do you? Equals, they want a final velocity. I see an initial velocity. I'm going to go m v final minus m v initial. And this time, none of them are 0, so nothing's going to cancel. Okay. Antonio, what do they want me to find? Right there. What's going to drop down like a domino? Ft. Then what? Yeah. What else? How will I move that over? Which one am I going to do first? Reverse bed mass. So it's going to be plus m v initial divided by m. That equals v final. You okay with that, Antonio? Cool. Antonio, how big is the force? Okay. Everybody stop. Antonio has just decided that west is positive with his answer. Okay? As soon as you said 350 newtons, and you notice it's 350 newtons west, you've just decided west is positive. This 4.65, positive or negative? And how do you know? So I would, as soon as you said that, I would stop, drop everything, and I would put a big negative in front of it. In fact, if I had a pen or pencil that changed colors, I would make it stand out the same way I did in red, just so I don't forget. Time. Negative, positive, times a scalar, no direction. Much like your futures. No, that came out wrong. Then there's a plus sign. Mass, scalar, no direction. 4.2. V initial, negative 4.65. All divided by 4.2. Yeah, Franz, you're getting your calculator out. Every one of you. This is the level of complexity I'm expecting you to handle on your calculator. Now, Courtney, is this a fraction? Big brackets around the top. Is there more than one number on the bottom? Don't need brackets around the bottom. So if I was typing this, I would not use brackets to show timesing. I would go bracket 350 times button 0.075 plus 4.2 times button negative 4.65. I would then close off the top, divided by, don't need brackets around the bottom because there's only one thing. By the way, if the ball bounces off the wall, what direction will the ball be traveling in its final velocity? What was the initial velocity direction? So if it bounces off the wall, which direction is it traveling? Did you let west be positive or negative? I'm expecting a positive answer here. If I get a negative answer, I'm going to freak out. Did I get a positive answer? Nice. Now, you could also have let west be negative. You could have let that 350 be negative, and we would have ended up with a negative 1.6 as our answer, and we would have said, oh, that's west. V final is 1.6 meters per second. That's the magnitude. Direction, west. Somehow I'm thinking example 7, I didn't leave anywhere near enough room for you to write stuff. Okay. That's all right. Rifles are great examples of momentum and impulse. So we're going to fire a rifle. Bang! A rifle accelerates bullets from rest to 250 meters per second. The rifle barrel is about 0.85 meters long. A says, find the impulse acting on the bullet. Well, impulse. Which version of impulse am I going to use? I got to be fussy, not MV, M delta V, which I break into MV final minus MV initial. Oh, and look. Starts from rest. Yay. That ended up actually being a lot easier than I planned. M 12? Okay, it's grams, so please don't tell me that a bullet is 12 kilograms. A bowling ball is 12 kilograms, but not a bullet. So to go from grams to kilograms, divide by 1,000. So it's going to be 0.012. V final, 250. 4? 3? I mean, 3? 3? Sorry, 3? Is it 3 even? I'll go 3.0. Units, kilogram, meters per second, or Newton seconds. I should have, again, here said find the magnitude of the impulse, but down the barrel if you wanted to give me a direction, because I know how rifles work. Trust me, the impulse is not backwards up the barrel. That would be a Three Stooges kind of a rifle. You know, that's the Elmer Fudd rifle when Bugs Bunny or Daffy Duck pokes his finger and, okay, we're not doing that. We're in the real world. Skip B. Because I didn't give you enough room. By the way, it wants you to find the force. So you would say, I just found the impulse. I would use force and time. I don't know time. They told me distance and VI and VF. I could figure out how much time and go with that, but running out of time. See how I did that? Nothing? Okay. Consider the diagram at right for the next 3 questions. The diagram depicts the initial and final velocities of an 800 kilogram car in 2 different collisions with a wall. In case A, the car rebounds upon the collision. In case B, the car hits the wall, crumples up, and stops. Let's assume that the time of collision is the same for both of them. So let's remove that variable. Which one experiences the greatest change in momentum? Case A, case B, both the same, or I can't tell. Yeah. There's a couple of ways we can think about this. We could actually calculate it because the final velocity is equal, in case A, is equal to what? So I could go, okay, impulse is M, 800, V final minus M, 800, V initial. Why is that wrong why is what I typed just wrong? Courtney, you back here? Why is it wrong to go 800 times 4 minus 800 times 5? I can't hear you. I'm sorry. Either the 4 needs to be negative or the 5 needs to be negative, but one of them better be negative because there's definitely a change in direction. Okay? So I'm going to make the 5 negative because that's less backspacing. There, the impulse is 7,200. In the second case, it's going to be 800 times 0 minus 800 times negative 5. 4,000. Who are my football players? Okay? When you tackle someone and bring them to a stop, that's impulse. Or when you tackle them and you drive them backwards, that's a bigger collision because you gave them more impulse. See the difference? Okay. This is counterintuitive for some people. Some people think, oh, hitting a brick wall and coming to a stop would do way more damage than bouncing off of it. Actually, no. More impulse bouncing off of it. Which car experiences the greatest impulse? I'm asking you the same question. Instead of saying change in momentum, I just said impulse. The impulse in case A has a magnitude of, I think we calculated it to be 7,200 in case A. Change in direction. Which type of collision? Turn the page. Are we turn the page? No. Which type of collision is worse for a passenger? A head-on collision where the two cars stick together, or a head-on collision where the two cars rebound apart on impact? Kenley. Rebound apart. For the same reason here, bigger impulse. Now, there are two ways to think about impulse. So first of all, oh, geez. You can circle that. If we rebound, that means larger change in momentum. And what's another way to write change in momentum that involves force? That also means that force times time is larger. Did the time of impact get bigger? Then what had to get bigger in this collision if you bounced off? Therefore, force is larger. Okay? Head-on collisions where we come to a stop do less damage than head-on collisions where we bounce off each other. I know I've been talking a long time. One more and we're done. I think. Yeah. Is there a change in direction in this question? Be careful with your negatives and positives. Which one of these has the biggest change in velocity? What's change in anything, Jackson? Just final minus initial. So the change in velocity, I agree, is going to be VF minus VI. So get your calculators out, everybody. In case A, go VF minus VI. Wait. Is there a change in direction? Let's let final be positive, VF, minus. Let's let initial be negative. What's the change in velocity for case A? 15. What would a lot of people think the change in velocity is if they just glance at the numbers in a hurry? 5. Don't do that. I'll have that as answer A if it's multiple choice. What's the change in velocity in case B? Well, the final is 28 minus negative. The initial is 30. A lot of people might look at case B and say, that's a change in velocity of 2. No. Which one has the biggest change in velocity? Case B. Explanation. We calculated it. If you want to, you can write change in velocity equals final minus initial. So which one would have the biggest acceleration? Which one had the biggest change in velocity? And since acceleration is measured as the change in velocity per time, which one's going to have the biggest acceleration? Same answer. I didn't ask you this question, but which one has the biggest acceleration? I asked you that question. Which one has the biggest force then? If F equals what? B. So which one has the biggest change in momentum? Because of force times time. Okay. But if you look at those numbers, and Courtney, if you don't really think about it, it's easy to see in the first situation 5, and in the second situation 2, and think, oh, geez, that second situation is way easier, way tougher. What's your homework? I'm going to cross out the ones that I don't want you to do. I'm going to ask you to do most of them. You can cross out number 16. You can cross out number 19. Oh, Calvin and Hobbes. I like Calvin and Hobbes. But you know what? I'll pass on number 21. We'll skip Calvin and Hobbes. Tennis or hockey? What do you want? Hockey? Okay. You can cross out 22. That's an awful lot. I'm probably just going to start a lesson next class, but I won't finish it. I'll give you some time also on Monday. Okay? There's a video. I'll show you that on Monday as well.